Hey, Nathan here. Welcome back to another C++, specifically DirectX tutorial. It has been a while since I've done a tutorial. The past couple months have been holidays, with Thanksgiving, Christmas, and then New Year's. So I took a little break on doing tutorials. It's just been busy with the holidays. But now it's past New Year's, and it's several weeks into January, so it's time to get back to doing tutorials. So last tutorial, we discussed the way to update sprites, and we do that by using just a standard value. We increment the position by just a standard value. We have not discussed timers yet. We'll get that in a few tutorials later on. In this tutorial, we're going to change the GameSprite class, and we're going to implement the GameplayObject class that will, just like what we did with the game class, we're going to use a GameplayObject class instead of the GameSprite class. So just like what we did with the game class, the GameplayObject class is going to be a wrapper and going to have additional functionality, additional properties and values and stuff like that we can use in our game. Alright, first thing, let's go ahead and implement the header file. So let's right click the header files. Let's go to add new item. It's going to be a header file, and we're going to call this GameplayObject. And then we're going to do our standard include guards, pound if and def, GameplayObject underscore h, pound define, GameplayObject underscore h, and then at the very end we'll have pound end if. Alright, before the end if, we're going to add all of our code in here. Now, what does a GameplayObject have? It can have think about what a GameplayObject has. We need a way to draw it, so we need access to the sprite and texture, but we already have that. We have that in the GameSprite class, so we just need to have a pointer to the GameSprite class. It needs to have access to physics data, position, acceleration, velocity, rotation. It needs to have access to informational data, if we want to give it a name and description, and all that stuff. State, is it active, is it dying, is it dead? So all these things need to be implemented in this class. We're not going to implement them all right now, so we'll just implement the basics. So right now we do need a rotation. So we're going to use a header file called cmath, and we need to include the pi functionality, 3.14. So we need to have another define here to do that. So define underscore use underscore math underscore defines. That is needed when we include cmath, and that will give us more math defines, pi and stuff like that, additional pi values. Alright, now we need to include GameSprite. We need to have access to the sprite and texture data, but that's already wrapped in the GameSprite class, so we just need to include the GameSprite. Next, we need to pound include string for our informational data, a string name and a string description. Okay. Now for status, you can have status in a whole lot of ways. You can have it just a integer value, a whatever you want to do. I like to have status and states in enumerated types. So enum class object status, opening curly bracket, and then just provide your states. Active, dying, dead. Closing curly bracket, and then semicolon. So those are just our states. The object can be active, dying, or dead. Alright, class GameplayObject and semicolon. Public. Alright, so the public section, of course, needs to have our constructor and destructor. GameplayObject, open parentheses. We need the constructor accepts a x and y position, the default, the initial rotation, the speed, and the maximum speed the object can use. So float x, float y, float rotation, float speed, and float max speed. Destructor. Tilde GameplayObject. Now, we're going to assume that this class will be used in object-oriented programming, so we can assume that we will override it, we will inherit from it. So let's make these virtual, bool, and then the standard initialize. Alright, so initialize needs to also initialize our game sprite, and in order to initialize game sprite, we need to have access to our graphics, our Direct 3D device. So we need a LP Direct 3D device 9 device. The file name, remember, it also needs to call the sprites initialize, the game sprites initialize, so we need to pass in the file name and the int width and the int height of our image file that we want to use. So std : string file int width int height. Alright, virtual void update. Of course, with any kind of game element, we need to have update and draw. And then we need to pass in the usual float game time, and then virtual void draw. Float game time. Alright, now in some cases you want to retrieve the object status in somewhere else in the code. You want to somewhere else, you just want to get if it's alive, dying, or dead, and do something with that information. So in order to get a enumerated type from a class, you need to use getters, and the correct way to use getters is to provide the type you want to get, object status, get status, whatever you want to call it, and then const, C-O-N-S-T. That is the correct way to use getters. Alright, one last public method is to set the speed of our object. You know, someplace else you might want to set the speed of your gameplay object to something else. Alright, that is it for the public section. Protected. Protected means we have access to it when we override. Alright, so in this protected section, we're going to provide some of our data, specifically the name, description, and our physics data. So informational data is, the name of the object, the description, whatever kind of information you want to give. Alright, so string name, and then string description. Now, physics data. We talked about this at the beginning. Position, velocity, rotation, and speed. These are all physics data. And we're going to use a vector for that. And we're not going to create a wrapper for the vector, at least not right now. So we're going to use the direct3dx vector 3 position. And direct3dx vector 3 velocity, float rotation, and float speed. Alright, now we need to have another section for our private accessible data. So I'm going to put the object status in this section. I'm going to put the sprite pointer in this section. Now I'm going to put the maximum speed in this section. Alright, and then that is it for the header file. So let's create the source file. So right click the source files folder, go to add new item. It's going to be a C++ file, and it's going to be GameplayObject. Alright, so let's implement our GameplayObject. So we're going to pound include our GameplayObject header file. Alright, now we can start implementing our methods and actually put code in them. So GameplayObject. We're going to do our constructor first. So float x, float y, float rotation, float speed, float max speed. So just copy what we needed to use in the function header as what we set it up in the header file. Now in the function body, let's create a float and let's get 2 pi. So there's no built-in constant for 2 pi. So we're going to have to cast float here, call m_pi. We get that from the CMath headers, and we get that from also the useMathDefines here. Now, if you are not familiar with this header file, mpi_2 is not 2 pi, that's pi over 2. So don't use that one. So we'll need to use m_pi, then multiply it by 2. And then semicolon. And then cast that as a float. Of course, we need to call float 2 pi is equal to float there. Okay. Now we need to set up our position data. Position.x is equal to x. Position.y is equal to y. And then since it's a 2D game, position.z is equal to z, or 0. Alright, now we need to do a rotation check. If you pass in a value greater than 2 pi, the rotation gets set to 2 pi. If you pass in a negative rotation, the rotation will get set to 0. So just creating a rotation has to be between 0 and 2 pi. If rotation is greater than 2 pi, rotation is equal to 2 pi. If rotation is negative, so if rotation is less than 0, rotation is equal to 0. Alright, now we need to do the same thing with speed. We have a maximum speed the object can travel. If the speed you pass in here is greater than that, we need to set the speed to the maximum speed. We cannot have a negative speed, so if it's negative, we set it to 0. If speed is greater than max speed, speed is equal to max speed. If speed is negative, so if speed is less than 0, speed is equal to 0. Okay, this rotation is equal to rotation. Alright, I'm not sure if all of you are familiar with the keyword this, but we named what we pass in rotation. We named that value rotation. In our class, the same name is used in our protected data, our physics data. So how can we distinguish between our class rotation variable and the variable we pass into the function? We use the keyword this for that the way we distinguish between one and the other. This arrow rotation refers to our class's physics data rotation. And just the word rotation, nothing else, refers to the variable we passed into our function. So this refers to this object. So this object's rotation is equal to the rotation we pass into the function. We need to do the same thing for speed. This arrow speed is equal to speed. If you're confused about this, just change the name of init speed or something like that instead of speed. And then all you have to do is say speed is equal to init speed. Alright, now we need to set velocity, and velocity uses the rotation and the speed. Alright, back in 2009, I implemented a vector tutorial. Let me zoom in here really quickly. So I implemented a vector tutorial that both covers math and XNA. So I'm going to cover the math side of it, and I'm going to discuss how to use speed and angle to get the vector. So let me scroll down here to find the math section. So this section talks about how to find the angle from a vector, but sometimes you will have the angle and some components, but you wish to find others. Below is a listing on how to find a component using the angle. Finding vector components from trigonometry functions. So to get the y component, we take the x component times tangent and then the angle. To get the x component, we take the y component divided by tangent angle. But we're not worried about tangent. What we're worried about is cosine and sine here. These are the easiest ones. So what we have is the speed. That's the length of the vector we need to have. And then we have the rotation. We have the angle. So to get the x component of the vector, we take the speed, or in this case, the length of the vector, multiply it by the cosine of the angle, cosine of the rotation. Let me zoom in a little bit more so you guys can see it. Alright, now to get the y component, we use sine instead of cosine. And we use the length of the vector, which in this case is the speed value, and we multiply it by sine of the rotation, sine of the angle. That gives us the y component. So, let's go ahead and go back to our code now. Alright, so now that we discussed the math side of things, let's actually code it in here. So velocity.x is equal to cosine rotation times speed. Velocity.y is equal to sine rotation times speed. And then since it's a 2D game, let's set velocity.z is equal to 0. Finally, this max speed is equal to max speed. Alright, so let's go ahead and go through this a little bit faster now. So let's worry about the initialize function right now. GameplayObject initialize. It's going to be LP direct 3D device 9 device std string file name int width int height. So the initialize is basically just going to set our status to object status dot active. Oh, I'm sorry, not dot, 2 colons. It's difficult going from X and A to C++. Alright, if not sprite. So if the sprite pointer has not been initialized yet, sprite is equal to new game sprite if not sprite arrow initialize device file width height. So if the sprite cannot be initialized, remember this initialize function we made will return false if for some reason it didn't initialize, so we need to return false. Return true. Okay. So you can actually change this to return sprite initialize, but I like to do it this way in case we have additional features later on that we need to implement. It just works out better this way. Alright, now the update. Void gameplay object update. It just accepts a float game time. And then if status equals object status ;, active. Let me scroll down a little bit. Alright, so if it is active, we need to update our object. Position.x plus equals velocity.x. Position.y plus equals velocity.y. Position.z is equal to 0. You really don't need to do all this position.z or velocity.z is equal to 0 stuff, but I'm just doing it anyway. There's really no harm in doing it. Make sure it's 0. Void GameplayObject draw float game time if sprite has been initialized. Sprite, the game sprite class does all the drawing. So sprite draw game time. Alright, now for the get status function. Object status gameplay object :get status const for constant, return status. Void gameplay object set speed. We pass in the speed we want the object to, the new speed value. If speed is greater than or equal to 0 and speed is less than or equal to max speed. So if the speed is positive and less than our maximum speed, this speed is equal to speed. And we changed our speed value, so we also need to change our velocity. Velocity.x is equal to cosine rotation times speed. Velocity.y is equal to cosine or sine rotation times speed. Velocity.z is equal to 0. Alright, last thing, gameplay object the destructor. Gameplay object. That's just going to get rid of our sprite pointer if it exists. So if sprite delete sprite is equal to 0. Alright, so we're not done with the gameplay object class. As you see here, we have a draw. We call the game sprite draw. But we do have a position here, so we want to draw it at a specific position. So we need to modify our game sprite. So let's go into the header here. So the game sprite header, draw here. We need to add a position to draw it to. So d3d x vector 3 position. So that's the draw function declaration. Now we need to modify the actual implementation. So gamesprite.cpp over here, we have our draw function here. d3dx vector 3 position. Alright. So we need to draw it at a specific position. Alright, so that looks good. Everything looks good. Now, we are changing. Remember, GameSprite used to do what we did before. We're wrapping this up into a gameplay object, so that's why we have position here and everything else here that we have used before. So we need to remove all this stuff once we get the gameplay object finished. So go back to the gameplay object.cpp file. Inside the gameplay object draw function, we call the sprite draw. We need to pass in the position to draw it to. Alright, once that's done, we can save it. Alright, now let's modify our GameSprite class. Alright, the GameSprite class will not have velocity anymore. That's being taken care of in the gameplay object. It will still have a constructor and destructor, but it will not have this one, because that is a position one. It'll have initialized, and it'll have a boolean is initialized. It'll have draw, but not update. It'll have a pointer to a texture and sprite. It'll have attributes for color and is initialized, not position. Alright. So position is not being implemented here. We just need to set the color and is initialized to false. This constructor does not exist anymore. Initialize, everything looks fine there. Is initialized, everything's fine. We do not have an update function anymore. We keep the draw function the same, and everything's the same. Alright. So that should be it on that. Now let's go to the main.cpp file. Or, I'm sorry, game CPP file. And game.h file. Alright. So we're not going to include our game sprite anymore. What we're going to include is GameplayObject.h. And then our game is going to have graphics device, and then instead of game sprite, it's going to be GameplayObject. GameplayObject. Everything else looks fine. Now let's go to the CPP file. Alright, so in the initialize, we set up our device, and then we need to set up our player to be a new gameplay object. Pass it X, Y, float. This is going to be the rotation, so whatever you want to be the default rotation. It will not look like that right now. We did not discuss about matrix transformations just yet. M underscore, let's just check here. Yeah. M underscore pi underscore 4. So it's going to be pi over 4. 1.5 f for the speed, and the maximum speed is going to be 1.5 f. If not player initialize, then we just pass in all of our data that we have before. Velocity is not going to be set manually. That's set with the rotation and the speed values. Alright, so player 2, gameplay object. We're just going to change the new to the gameplay object constructor. Let's do the same X and Y. Let's change the angle to 0. So 0 rotation. 1.5f, 1.5f. Velocity is not going to be set manually, so we can delete those lines. Run, update, draw. So draw is going to be a little bit different now. So if player, we get rid of this line. So all we need to check for is if player and if player 2. That's all we need to do. We do not need to check if is initialized. Alright, so now let's build, rebuild, see if we have any errors. We do not have any errors, so now let's press F5, or let's go to the debug and start debugging, and everything's working fine. So as I said, you do not see the rotation, but you see the bottom sprite is moving diagonally down and to the right. We did not discuss matrix transforms just yet, so we do not get the visual that we have a different rotation. But they are going the same speed, all that's different is the rotation. Alright, that is it for this video. I hope you enjoyed it. I do apologize for if I sounded a little bit stuffy today. I've been recovering from a cold. But I said today was going to be a new tutorial date, so I wanted to get this done. I hope you enjoy this tutorial. Let's see what's next on the tutorials listing. Alright, so if I go to my subversion here, my DirectX here, trunk, so this was tutorial 6, so GameplayObject. Tutorial 7, we discussed timers, basic timer. How do we get the elapsed game time? Tutorial 8, we discuss how to update sprites with the timer. So we discussed this earlier on in the series, but when you update your game objects, you update them with seconds and not hard-coded values like we did. So we just say every game loop, our sprite will move 1.5 pixels from its current location. That's not how you're supposed to update sprites, but we did not get to timers just yet. So we'll do that next tutorial. And then the tutorial after that, we'll change the way we update sprites and use our timer instead of hard-coded values. Next tutorial will be keyboard input, and then I'll have more tutorials after that. Alright, thanks for watching, and I hope you enjoyed this video. Stay tuned, I'm back to recording, so next weekend will be more tutorials. Stay tuned for a couple of additional videos today. I want to discuss a couple more things. One of them will be a new game project, so if you're interested in what I'm going to be programming in for this year and probably next year, go ahead and watch that video. I'll need some advice from people, what they might like to see. And the other video will be just a general announcement on the website and tutorials. So if you're interested in knowing what tutorials are coming out or what the new website design is going to look like, stay tuned for that video as well. There will be separate videos so you can watch one without watching the other. So stay tuned for that. Alright, hopefully next weekend I'll be back to normal. I won't have a stuffy nose. So cross your fingers on that. Thanks for watching. See you next weekend.